Hey guys, so today I'm gonna help you guys out with some AP Calculus. So we will be doing the 2010 FRQ, which is on differentials, number 6. So the problem says, as you can see, solutions to the differential equation dy dx equals xy cubed also satisfy d squared y over dx squared equals y cubed open parentheses 1 plus 3 x squared y squared close parentheses. So let y equal fx be a particular solution to the differential equation dy dx equals xy cubed with f of 1 equals 2. So the first problem right here, A, is, so we're going to write an equation for the line tangent to the graph of y equals f of x at x equals 1. So, yeah, so this is number 6 of the FRQ. So for letter A, what we need to do, we need to write a equation line. So I don't know if you guys are familiar with this. Equals minus x1. So we have our, right here, we have our given. So we have our x and y coordinates, which is 1, 2. But we do not have our slope. But we do have our equation right here. So since we have our coordinates, all we have to do is plug it in. dy dx equals so this gives us 8, so our slope is 8. So now we have our coordinates and our slope. All we need to do is plug it into the slope line form. So y minus 2 equals 8 over x minus 1. Box it in. Now we go on to letter B. So we're going to use a tangent line equation from part A. So this means we already have our equation right here for part A. We're just going to bring that down. Y minus 2 equals 8 over x minus 1. But this time, instead of just putting our x, since we have we're trying to find f of 1.1, we're just going to substitute that in instead of our x. So just write it down again. So 1.1 minus 1 is 0.1. So just bring everything down again. We multiply this and you get 0.8. And you guys can't use a calculator because it is problem number 6. Okay, so now we bring this back down. And we're trying to get rid of the negative 2 to isolate our y, so we add 2. So this gives us y approximates 2.8. So this is part of the first part right here. Right here. That gives you some points out of the 9 points. So we want to box in our answer. And now we want to do the second part, which is given that f of x is greater than 0 for 1 less than x less than 1.1, is the approximation for f of 1.1 greater than or less than f of 1.1? Explain your reasoning. So we have our slope right here. So the slope of 1 gives us 8, which is an increasing function, and concavity of a function can tell you whether the linear approximation will be greater or less than. So in this case, we already know that our the slope of 1 gives us a increasing function. So now we are going to use concavity at this point. So we already have we don't have to look for the second derivative because we're given second derivative right here. So I'm just going to write this once again. It is d over y over dx squared equals y cubed. Okay, so now we already have our x and y coordinates right here. Once again, we're just gonna plug it in or substitute it. So there's no need to do the algebra because all of these are positive numbers. So at the end is going to be greater than 0. So this means it's concave up. So since it is concave up, it is going to look like this. And then the tangent line lies below the graph. So we're going to write our reasoning. So f is concave up and the tangent line lies below the graph. So therefore the approximation of, you have to be specific, so of f.1 is less than. So we box in our answers. We got our approximation of 1.1. Then we determined if it was less than. So that's enough to give us our points. So we can move on to letter C, which is the most important one, because if you know this part, you could probably get the most points out of this. So C, this is how you do it. So we're trying to find the particular solution of y equals f of x with the initial condition of f of 1 equals 2. So we already have our equation right here, and we want to separate this equation. So what we're going to do is we're going to try to separate it. Want to isolate the y. So part of it we want to separate it, as I mentioned earlier. So this will look like this. But we could simplify this by bringing this to the top and making it negative. So we're going to add our antiderivative sign. So this is important. Right here we separated it. So now it's time to just do the antiderivative. So this is pretty straightforward. So as what we normally do is we just add a 1. So this is going to give us y minus 2, because negative 3 plus 1 is negative 2. You bring this to the bottom, which equals x plus 1 is 2. You bring it to the bottom, and then plus our c. Don't forget the c. So now that we have that, so we had our initial condition right here. So this means that we have our x and our y. X and our y is 1 and 2. So now we can substitute the x and our y into the equation. But before we can substitute it, since this was a negative, we need to bring it back down in order to make it a positive. So what you do is you just bring it down to y squared. So now it's positive equals 1 over 2x squared plus c. So now you're ready to substitute it. So our y is 2, so 2 times 2 is 4. 4 times 2 is a negative 8 over 1 equals 1 times 1 is 1. So we just have 1 over 2 plus c. And we want to get our c by itself. So what we do is we're just going to subtract the 1/2. So 1/2 plus 1 over 8. So you know we have an 8 at the bottom. We want to get it the same. We multiply it times 4. So now we're going to have negative 4 plus negative 1, which is going to give us negative 5 over 8. So this is our c. So now we're just going to plug it back into our original equation over here, which is going to be 1 over negative 2y squared equals 1 over 2x squared minus, since we got our c. So this right here is a general solution to any equation, but we can't stop right here because, as the problem says, we need to find the particular solution. So at this point we have to isolate the y by itself, so we're trying to find y. So what we can do right here is to isolate the y is multiply times negative 2. So we're trying to cancel out negative 2. So negative 2. So that cancels. And now what we do to the left, we have to do to the right. So negative times a positive is a negative. 2 over 2 is 1. So we're just going to have x squared minus, not minus, my bad. See, I almost forgot our negative. Negative times a negative is a positive. So now we have 5 over 8. And we don't have to multiply our negative 2 because we already did it right here, but we could just cancel. That's going to give us a 4. So let's clean this up. And then this is going to give us 1, and we cancel the negative, so 1 over y squared equals negative x squared plus 5 over 4, because we canceled the 2 and the 8. So now we need to get rid of the 1 to get the y squared by itself. So we're just going to divide it by 1, you know, cancel it. And we're going to divide this by 1. Okay, so now we have y squared equals all of this, just bring it back over here, which is this over 1. But we're not done yet, you know, you gotta cancel this. That's how you cancel squared, by square rooting it. Cancel it, you bring this to this here, clean it up, you know, so the could be legible. Oops, the negative belongs to everything, and then the positive and a minus. Now to end with, we had our f of 1 equals 2, which is greater than 0, so that means it's positive. So we can take out our negative. So the answer is a positive. It's positive. That's our final answer.